Hello, everyone. I'm sorry Dermot couldn't be here today. I would have liked to have participated in something like this, especially given his close collaboration with Clint on many occasions. So Sweeny&Co has, in many respects, been at the forefront of working towards better architecture in delivering sustainable buildings, particularly in the commercial field for offices. Building a lot on what Sandy just told you about. In fact, they're one of our clients on a new store in Toronto. It's very much embedded in our philosophy about doing architecture that we try to make a better environment, not just for resources and efficiency, but for the occupants of the building. And that's very much, we've found, necessarily a collaborative effort, working with people that have the knowledge to enable us to deliver that product, to give owners something they can be proud of high quality and of value to their brand, and to their occupants, serves them well in the end. So let me just get started. This is 134 Peter, probably one of our showcase projects of the moment, and we'll get into that a little bit later. BIM has been very much part of how we work. It's taken a while to evolve it into the workflow in the office, but we're starting to see the value of it, mainly in current experience just for our own purposes, but more and more in terms of the collaboration with the other players that are involved in putting the building together. In that context, what has BIM helped us with? It's given us some accuracy in doing the work we do, of course. For the innovations that we bring to the field, it's allowed us to run analyses that can prove, well, not prove, but give some indication that concepts are moving in the right direction. It's given us more certainty in explaining our ideas, certainly to the owners, as well as to the consultants we work with, and to a certain extent, the contractors. This is a quick portfolio of some of the projects that we've worked on. The bigger ones that have actually been built would be the Microsoft headquarters in Mississauga, Aero Center 5 in Mississauga, which was done for Hoop Pension Fund. The BMW headquarters in Newmarket, 134 Pier again. We were design architects for assisting on the TELUS project in Toronto and RBC, their new building on Simcoe Street. All of these incorporated some of the ideas that we're going to talk about of what we brought to the field. So what were these key parts of the better building? Well, I think it's starting to become recognized that the efficiencies brought through underfloor air, natural light, high ceilings, contribute to efficiencies in energy use in the buildings, but also comfort for the users, which leads to improved productivity and increased wellness and retention for employees in the offices. These are some things that we recognized very early on and wanted, I'll skip that, and wanted to bring to the field well before anybody knew that this was going to be what would be a big part of the marketplace. So the key parts of that design innovation were the use of the underfloor air, which provides for local comfort. Everybody has control over their own climate by the use of floor registers that are located throughout the floor. I'm sure a lot of you probably know what this is all about, but I'll just go through it quickly. The fact that you're delivering the air, which in an office environment is mostly for cooling, at the actual occupant level is more efficient because you're not pushing it through the stratified hot air that you'd get in an overhead air system. So you can deliver it at a warmer temperature, so you've got a corresponding decrease in the amount of energy you got to put into cooling it. The perimeter is fin tube heat where you need it. Floor to ceiling glass, which provides lots of natural light, but also just gives a feeling of connectedness to the environment, and has proven to be enormously successful in selling these office spaces. When people walk into them, they're just like, that's great. This is what we want. Indirect light for glare-free light, and then sunshade devices to cut down on glare as needed. So this is the building that Clint was talking about. That was sort of the initial proof of concept. This was an old building in Toronto that was run down. It was an old 70s building, very inefficient, precast clad, single pane glass. We got involved through relationship with the owner, new owners, to redevelop this building. We took off all the skin, put in a higher performing skin, and incorporated some of those ideas that I was just explaining, the raised floor system, motorized sunshade devices. And it proved to be a huge success, just in terms of the actual data that we got back out of it. Because of our close relationship with the owners, we were able to draw out the data to show what was actually happening and how we had improved the situation for this building. And it made such an improvement that they were able to successfully draw in municipal or provincial government offices to the building, which had substantial long-term benefits for financial gain, shall we say. The next round was Microsoft headquarters. They saw what we were doing, liked it very much, thought it was part of their corporate identity, and we incorporated these same features into this building in Mississauga. Then, building on that, we did Loblaw's new headquarters in Brampton, same ideas, lots of natural light, underfloor air distribution, open office concept. So everybody had a view to the outside. The offices, if they were enclosed, were built around the inside core. And then Aero Center was the next building, same ideas. So what does this have to do with collaboration? So these were innovations that we brought to the market. And because they were not the norm, they brought a certain level of risk and uncertainty to the owners. Nobody, especially they're being advised by real estate agents who thought they knew what the market wanted, was eager to take on something new like this. Would they be able to sell it to their tenants? It was a hard sell. So to first come up with the ideas and develop them, we had to work very closely with strong engineers and manufacturers, contractors that were involved with these systems to bring them together to make the package work. And the opportunity that we had from doing that first building was sort of the first test of how that all came together. But it was very much drawing on, the ideas of everybody involved in all stages of the construction cycle, sharing their information so that we could build on what they knew would work to help us with our ideas of what we wanted to do about making a better office space. Now this is just a diagram that applies to many process-oriented industries. It evolved, I guess, out of the States in the 40s, but was, taken to heart big time by the Japanese for their car plants. Not to say that we're like an assembly line, but there's much to be said about the idea of collaboration where people further down the process provide information to the people in the design stage to inform their decisions and help them make better decisions. And they're driving it back down the chain with the ideas of what should be possible or could be possible. It's a collaborative process, we've found. So with BIM, the idea is that for the model to act as the conduit for that flow of information. It's one source that everyone can use, everyone can add to. Everybody provides input into, and as information is passed back and forth, there's less chance for that information to be lost if it's attached to the one model. It allows us to do more efficient drawings if they are to be deliverables as 2D, which is still very much the case. It informs our decisions, but essentially what it comes down to is I think, better communications between all players. It allows us to do these analyses. These are various programs. I think some of them are represented here today, IES in particular. And we've experimented with some of these. I can't say it's become a big part of our workflow, but it certainly offers a lot of possibilities. Just a quick anecdote about the use of energy studies. We had done, we were doing a new building, and it was interesting to do relative comparisons of various features that we would trying out on the design of the skin of the building. We were interested to learn that sunshade devices that we were using as a matter of course on the outside of the building, sun shadow shelves, didn't have as much effect as we thought. In fact, they were having a negative effect. And why was that? And we realized that by comparative studies, changing the properties of the glass, that we had achieved most of the energy shading savings through the shading coefficient just of the glass. And the exterior light shelves were in fact preventing the sun from coming in when it was needed to provide heat in the cooler months. So that was an interesting revelation, and something we only discovered by doing one of these energy analysis studies. So that served us well. And the idea, of course, is that you're doing all this work before it gets built. So, I mean, we've all seen the McLeamy curve. The effort put in the early design has the most cost effect, rather than making your efforts during construction. So, definitely, BIM is a big part of us working to figure out what needs to go into the building early on. So, cute little quote. But I think it sums up the idea of that we should all be sharing the goals and experiences that go into a building rather than just working in our own little silo. So I'm just going to go through a quick example of a collaboration we did to achieve what became a big part of our building at 134 Peter. A collaborative effort with the contractors and the engineers to achieve what has become quite a remarkable building. So we were approached by Allied Properties to do this building. They had acquired an old 4-story brick building in downtown Toronto at Peter and Richmond. It used to be the old Weston Bakery biscuit factory. They wanted to develop the site, and Allied Properties, I don't know if anybody knows, is part of their brand is just buying and redeveloping old brick and wood warehouse buildings. So they saw this as just another one of those projects. But we thought, well, you could add a lot more value to this. You've got a lot of space in and around the building and above. Why not take advantage of that? And so we introduced this idea of building on top of the old building, not bearing on it, but suspended or carried up above the building. So what this offered was the opportunity for them to preserve that old building, which again spoke to their brand. It improved our chances of getting this through municipal approvals. Not that the building was necessarily designated, but it was still something that the city saw as important in maintaining the fabric of this area. And then it gave them a chance to create a wonderful public space underneath, which we had enclosed with glass, and in fact helped again sell it to the city, as that could be a semi-private space that could be used for public functions. And in fact, that was written into the agreement with the city to allow that to happen. And in fact, has become very successful for various events, arts festivals, what have you. So how do we get this building up there? It became an exercise of collaboration to develop the idea of these legs. The yellow legs here are what we call the delta frames. So the idea initiated through working closely with the structural engineers. The idea to make it as efficient as possible is what drew the legs together into these nodes to offer the lateral bracing necessary to carry the mass of the building in as light a structure as possible. So we started out with our model. We had produced a number of iterations through 3D printing basically for the owner to get his head around the idea. The structural engineers got involved in figuring out how the joinery was going to work. And at a certain point, we realized that we needed the expertise of a contractor. So we brought in as a design assist through collaboration with construction managers Eastern, Walters Steel, who in turn brought in Cast Connects. Well, sorry, I'm jumping ahead a bit, but Walters Steel were working very closely with our structural engineers to figure out how this could all come together. At a certain point, economics were driving us to do a welded connection, which we were not satisfied with the look of. And we kept pushing back against the budget, in this case, with the owner to try and get something that we thought would be more aesthetically pleasing. And in the end, we went to this idea of the cast node, which would give us the much more fluid connection at the prime node in the middle of the structure to do that out of cast steel. Now that's quite a remarkable thing. That's about 50,000 pounds of steel in that. And we relied very much on the expertise of Cast Connects, who are great guys to work with if you ever get a chance. They saw the vision that we had and worked quite hard to make it happen. They produced the studies and the structural analyses that went together with Walter's ideas for the rest of the Delta frame. And even though it was still a premium, we managed to convince the owner that it was well worth it in the end, just in terms of providing a beautiful piece of what was the prime structure in this space. So the model carried on into the work of the contractor, They used it to do analyses for, what was the most efficient way to construct the steel. It was and sent down to the plant in Kansas somewhere where they could do the nodes. They cast this thing out of the steel. It would have been remarkable to go and see all of this. It was quite a feat. So they ship these back to the site on train. This is models that Eastern had done based on our initial model and the models coming from the structural engineers for how the building would be supported. Actually, the model with the colors is an indication of the sort of phasing that they wanted to work in to be as efficient as possible in erecting what essentially becomes the table supporting the building above, which was concrete. So Eastern, who was the ones coordinating all of this for the construction, they at the same time were doing their own studies through the model of how the legs would land on the concrete pad that was the foundation for all of this. In particular, they had to do studies for the steel cage which would route the rebar up and into the bolted connections for the legs. I mean, it's incredibly complex stuff, and you just got to imagine the weight of all of this coming down onto these spots. These were critical parts of the building. So this was the process of finally putting it all together. They did a test fit in their shop, and then broke it all down again and brought it to the site piece by piece. Erected it fairly quickly. It was a lot of craning at night because they had to close the roads down. They had temporary parts to hold it all up as they put the rest of the table together. But a remarkable feat of engineering. So this was the end product. The legs are coated with intumescent paint to preserve as much as possible their look. But you can see the space. It's just a remarkable public space now. We're actually in this building, which is kind of nice, living the dream. And the owners are pleased beyond words, I think, about how it all turned out. Moving on, this is one of our latest projects, which is One York. The collaborative effort here is again working through construction management very early on in the design stage to handle a lot of the issues that are really about us sort of seeing our design come to life. In particular, at One York, which is for the most part a pretty straightforward office building, again incorporating our ideals for the sustainable office. The grand feature here was the lobby facing the street. And we worked very hard to try and preserve the feeling of transparency to the outside, to draw the people into the building, create again a flow of space from public to private. And I think it's about 16 meters high, that glass wall. So that involved a lot of work with design assist again, with the subcontractor, which was Novum, I believe, and working through the CM at this time, which was Ellis Don, I believe. So again, there was a lot of push backwards and forwards, their expertise trying to align with our vision, and we drove very much for just a pure cable wall, and that's what we were able to achieve in the end. Structural had to do some major modifications in these hidden areas above the glass to accommodate the tension forces necessary to retain that glass in position. There's a lot of lateral forces if you're just working with something as thin as a cable wall, so that they counteract that with corresponding increase in tension. So there's a lot of structural steel that had to be provided to accommodate that up above. So where is all this going? The use of BIM, the collaboration with people. Well, it's been talked about here already. The ultimate goal is to serve the users of the building, to serve the owner, to serve the occupants. And there's information that is embedded in the model that could be used to operate the building. The big example of the day seems to be the Edge building in Europe, which has everything accommodating the user programmed for their use. As soon as they arrive in their car, it knows what you're going to do. Well, not quite what you're going to do, but who you are, where you're probably going to be working that day, and prepares your workspace for you. All automated. All the building automation systems, if the model is designed properly, can work off the information that's provided. It seems to be the promise of the future is integrating into the model the information that will be of use to the owners and operators. And we're starting to see more and more a demand for this from the owners coming to us saying, this is great, you're working in BIM, and there's all this information, but you're missing the step that helps us in the end. These are people that are going to operate the building in the end. How do we make use of that? And it's a process of evolving those ideas, and it seems to me not that we've got there yet, or that we've actually done any of this, that the promise of standards like COBE, which I don't know if anybody is familiar with, but it's this concept that there's a flow of information that starts in the design stage and works its way through all the players that add to it, that ultimately ends up providing the operators of the building with information that they can plug into whatever they want to do control of certain systems. So all of that necessarily involves a management of information from the very early design stages. I think the basic principle is that the designers are, the architects are providing the containers of the rooms, that the mechanical engineers then provide the zones for, talking about mechanical systems. And then as that flows through to the builders and suppliers, they add their information to the components that are going into that room. And ultimately, that's in a form that can be taken by the facilities management people into whatever software they're using to run the building. Canada, I don't think anybody's as far advanced in this as they seem to be in the UK and the States. It's been mentioned, but it sounds like the UK is mandating this for certainly their public buildings, that there is information built into the model that can be of use to the facilities management operators in the end. So I guess that's it. I thank CanBIM for asking us here today. I probably had a lot more to say that I've forgotten, but I hope I've contributed in some way to your understanding of the uses of BIM, certainly from the design point of view, and how it's, I think, helped us do better buildings and hopefully collaborate with people like yourselves on projects in the future. So thanks a lot.
Thank you, Peter. If I may ask, I can tell the voice, can you take a few questions? Sure. Are you good?
Yeah.
If I may ask the first question, pardon me?
Sorry to interrupt, but there's a microphone on the chair there. Yeah,
Is this no good?
we can use both.
Oh, that's good.
Plenty of mic, and Peter can use the hand.
Oh, thank you.
Testing.
I didn't even see that this morning. You showed a few examples, 134 Peter, the Allied building.
Yes.
Awesome example of collaboration. Yet yesterday, at one of our tours, as some saw, we couldn't get access to the BIM models. We had to essentially reinvent some of the modeling to support the operations, the asset managers, right? So how would you describe critical success factor? Because we see such a wide gamut, you know, people in the BIM world, and yet the architect and the engineer versus the contractors, there's no alignment, you know, like collaboration, what? And then on a job like that, it was a home run. So what was that critical success factor or lessons learned? Really keen to hear that.
Well, it is a big question. Like, right now, the projects that we've done BIM on have been mostly for our own purposes. It just helps us do a better design building and provide the traditional 2D deliverables. And then it seems like if it's going to carry on, that the contractor, in some respects, almost starts again, which is kind of a shame. But they have their own purposes for doing a model that we don't necessarily understand, or they're not bothering to share with us or explain to us, or they're just not involved early enough for us to be able to provide them with what they need. So we're working now on some projects which are becoming more integrated, in that they're telling that the contractors are being brought on as construction management scenarios, where they're saying, this is what we need. You design how you get there, but this is what we need. So that's great. I'm all for that. I'm happy to do that because it does, I think, there's the promise of doing better buildings. And that's really what we're all here for, I think. I don't want to be just doing it on our own. I want to be able to share it. I want it to prove to be of value because everybody's contributing it to it, so I can inform my design better. So even just within the design field, the other players, engineers, you know, they should be contributing to that too, to be of ultimate value.
Absolutely.
So it's probably happening more and more. I think it is. Certainly mechanical and electrical engineers are slow to rise to the occasion. I think they see themselves still as providing a schematic design rather than a detailed design, because there's liability issues. There's constructability issues. You know, they can't foresee where all the pipes, you know, right down to the 1.5 inch are going to go. It's a lot of extra work for them, and something that's traditionally been done by the trades. So for 134 Peter, it sort of evolved. It wasn't really a mandate. It was like, we said, we're going to do this in BIM, and then Eastern, it just sort of aligned. They saw, I guess, the writing on the wall, and they were starting to get their guys involved with BIM. So they were, it was almost like a test case for them to try it out on this project, which was great. And I think it is almost of a necessity for the complexity of that structure. And certainly the manufacturers, they were working in BIM. They were doing Tekla for a lot of that steel assembly stuff, to see everything right down to the bolts and the connection, how it was all going to come together. And Walter Steel, as an example, they're all over that kind of stuff. They say they do steel structures in their models, and that when they're built, they're like, you know, 2 millimeters out of the proposed position. So
it sounds like a mindset. Happened to be a project where a whole team came together who wanted to work together and collaborate.
Yeah.
Right?
Yeah. Which is the good part of, you know, construction management, is the collaborative aspect of it.
Exactly. Thank you. Other questions from the audience?
Are there any architects here? Oh, good.
Okay. I have another question, if I may. Have you and your organization quantified through collaboration, how you've built or delivered a project faster. Have you been able to quantify that for the client in terms of what that meant for financial results?
I wouldn't say we've quantified it. It's human nature, tend to be optimistic when we make predictions. But we've been able to live up to them, I think, and BIM has helped us with that.
Okay, thank you. And if I may, one more question. With the integrated design process, have you been able to identify any reduction in waste, construction waste, garbage? Have you and your organization looked at measuring that in any way?
Well, no, not
Okay.
not to our knowledge.
Okay.
I think the CMs, certainly through the lead process, seem to be more involved with that.
Right.
Yeah.
Okay, thank you. We have a question here. And if we may, there's, maybe you've got the loud voice, but there are 2 microphones there if you wish. Pardon me, I just got you out of the chair, but thank you.
It had better be a good question if I have to go up to the microphone. So, Peter, you just mentioned very rapidly some of the international aspects of how BIM is developing and where. Can you just very briefly mention where it's most used? Is it stronger in Canada, in the US? And where is it going? And I'm also very interested in the, how you quantify, how you show the benefits to the stakeholders of using BIM versus something else. The clarity is understood, the cost, but how do you quantify this to convince people to use? So the first question is, internationally, who's the strongest proponent, and where it came from and where it's going, and then how do we make the argument for its use?
Well, that's a good question, and I'm not sure I'm prepared to fully answer that. My impression is that the States and the UK seem to be maybe 5 years ahead of us in looking at where we are now compared to where they were. And I've been involved with BIM for 10 years now. That they're well in advance of us. And it seems to me a lot of that impetus has come from the top down in terms of the government mandating this as a way of working. So they must understand that there's some efficiencies there. I'm not sure what that actually works out quantifiably, but it's in a way forced the industry in those countries to adapt to new ways of working, certainly through BIM. To be quantifiable about it, I don't know. I've never really thought about it that way. It just seemed to be evident. But if you're looking to make the argument, I don't know. Certainly as an architect, it makes a lot of sense to be working in 3D. You're gaining knowledge just from the fact that you're putting the building together virtually. You're getting the whole picture. You're finding ways of looking at the building that you can use to explain to someone else what's going on. Clash detection, things like that come out of that. It seems to me natural that has a benefit. Again, you go back to the McLeamy curve. If you can discover it during the early stages of design rather than in the construction field, that's going to save you a lot of money. The dollar you spend for design turns into $20 during construction and $60 I hear during building operations for some of these things. So if you can find the efficiency during design, then there's going to be a payoff further down the road, multiple times. So I don't know if that answers your question, but it's my experience.
Thank you. And having this type of conference together brings us together to bring this critical thinking and raise this awareness, so as we leave here, we're taking it back into industry. So often we'll hear about BIM and well, we don't charge for it, it's just part of how and what we do. But the common language, whether it was with a minister or a CFO earlier, or as we'll have another finance executive later today as well, that common language will always go back to the financial. None of these buildings are going to happen without the capital models, right? Value creation. So great question. Thank you. Okay, I'm sorry. I saw one more question. Yes.
Hi, I just wanted to comment on that question as well. I'm a professor at UBC, and we do research on BIM, and there's a lot more research that's needed to better understand the impact of BIM. There's been a lot of good data on this, showing that BIM can help to lead to better, faster, more cost-effective, more sustainable buildings. There's also been a lot of great data showing that more collaborative project delivery leads to better project outcomes. So we need more, though, to better understand how this impacts our projects. The other thing I want to point to is in the innovation article, the innovation publication that just came out, there's a great article by Eric Poirier here, I'm just going to plug him, that talks about BIM adoption and compares it in Canada to the rest of the world. And we're definitely lagging behind in terms of any sort of BIM mandate. But there's a lot of leaders out there, the UK, the US, Singapore, and others that we can learn from. So I highly recommend that if you do want to know where Canada stands, there's a great article in the spotlight there.
Okay. Thank you, Cheryl. Okay.
Flashing red.
Yep, flashing red. Peter, thank you very much.
Thank you.
Appreciate it.